Hi everyone, welcome to this new module 10 is over IPv6 addressing format and rules. In the first point is IPv4 issues. The need for IPv6. You already know that the IPv4 is running out of addresses. That is why you need to learn about IPv6. IPv6 is designed to be the successor to IPv4. IPv6 has a large 128-bit addresses space, providing 340 undecillions possible addresses. However, IPv6 is more than just large addresses. When the IATA began its development as successor to IPv4, it used this opportunity to fix the limitation of IPv4 and include enchantments. One example is Internet Control Message Protocol version 6 (ICMP v6), which include address resolution and address autoconfiguration not found in ICMP for IPv4. The depletion of IPv4 address space has been the motivating factor for moving to IPv6. As Africa, Asia, and other areas of the world become more connected to the Internet, there are not enough IPv4 addresses to accommodate this growth. As shown in the figure, 4 out of the 5 rears have run out of IPv4 addresses. Rear IPv4 exhaustion dates. Okay, we can see in the image in July 2015, in RIPE September 2012, in APNIC in June 2014, in AFRICNIC in 2020, and LACNIC in April of 2011. IPv4 has a theoretical maximum of 4.3 billion addresses. Private address, in combination with network address translation (NAT), have been instrumental in slowing the depletion of IPv4 address space. However, NAT is problematic for many applications and creates latency and has limitations that severely impede peer-to-peer communication. With the ever-increasing number of mobile devices, mobile provider has been leading the way with the translation to IPv6. The top two mobile providers in the United States report that over 90% of their traffic is over IPv6. Most top ISP and content providers such as YouTube, Facebook, and Netflix have also made the translation. Many companies like Microsoft, Facebook, and LinkedIn are transitioned to IPv6 only internally. In 2018, broadband ISP Comcast reported a deployment of over 65% and British Sky Broadcasting over 86%. And the next point is Internet of Things. The Internet of today is significantly different than the Internet of past decades. The Internet of today is more than email, web page, and file transfer between computers. The evolving Internet is become an Internet of Things. No longer with the only device accessible in the Internet be computers, tablets, and smartphones. The sensor-equipped Internet-ready devices of tomorrow will include everything from automobiles and biomedical devices to household appliances and natural ecosystems. With the increasing Internet population and limited IPv4 addresses space, issues with NAT and the lot, the time has come to begin the transition to IPv6. The next point is IPv4 and IPv6 coexistence. There is no specific date to move to IPv6, but IPv4 and IPv6 will coexist in the near future. feature, and the translation will take several years. The IATF has created various protocols and tools to help network administrators migrate their networks to IPv6. The migration techniques has been divided into three categories. In the first is dual stack. Dual stack allows IPv4 and IPv6 to coexist on the same network segment. Dual stack divide run both IPv4 and IPv6 protocol stacks simultaneously, known as native IPv6. This means the customer network has an IPv6 connection to their ISP and is able to access content found on the internet over IPv6. And we can see a network with one router attached to three devices. Dual stack, IPv4 and IPv6, dual stack, IPv4 and IPv6. Okay, this is dual stack. The next method is tunneling. Tunneling is a method of transporting an IPv6 packet over an IPv4 network. The IPv6 packet is encapsulated inside an IPv4 packet, similar to other types of data. Okay, IPv6 only network dual stack. Okay, in this case, the both routers has dual stack. The packet travel over a protocol IPv4 in this tunnel IPv4 only network. Okay. And this last is translation. Network address translation 64 NAT 64 allow IPv6 enabled device to communicate with IPv4 enabled devices using a translation technique similar to NAT for IPv4. An IPv6 packet is translated to an IPv4 packet and an IPv4 packet is translated to an IPv6 packet. IPv6 only network, IPv4 only network, NAT 64 router. Okay. Note: tunneling and translation are for transition to native IPv6 and should only be used where needed. The goal should be native IPv6 communication from source to destination. Okay, finish with check your understanding IPv4 issues. And question 1. What is the most important motivating factor for moving to IPv6? Better security with IPv6, better performance with IPv6, IPv6 addresses that are easier to work with, depletion of IPv4 addresses. Better performance, I need to translate this part. 1 second. Okay. Yeah, that's right. The main drive of most important factor for IPv6 is the depletion of IPv4 address space. Question 2. True or false? 4 out of 5 rears no longer have enough IPv4 addresses to allocate the customers on a regular basis. True. Okay, false, reset. True or false? 4 out of 5 rears. Okay, let me translate this. That's right, the correct answer is false. All of the 5 rears, Arin and Ripe, have exhausted their IPv4 addresses pools. Okay. And question 3. Which of the following techniques use native IPv6 connectivity? Is all of the above. Dual stack, Which of the following techniques use native IPv6 connectively? Uh, native, uh, I think is dual stack. And dual stack allows IPv4 and IPv6 to coexist on the same network segment. Dual stack drives run both IPv4 and IPv6 protocol stacks. Translation, tunneling, translation, all of the above. Submit. Only dual stack use native IPv6 connectivity. Go back recent entry again. Okay, this is dual stack. Which of the following techniques use native IPv6 connectivity? Dual stack. Okay, go to the next. Is IPv6 addressing. Hexadecimal number system. Before you dive into IPv6 addressing, it's important that you know that IPv6 addresses are represented using hexadecimal numbers. This base 16 number system uses the digit 0 to 9 and the letter A to F. Okay, we can see. And in IPv6 addresses, the 16 digits are represented as hextet. This queues next, allowing us to represent these massive addresses in much more readable format. Okay. Okay. First point is IPv6 addressing formats. The first step to learning about IPv6 in the network is to understand the way an IPv6 address is written and formatted. IPv6 addresses are much larger or large than IPv4 addresses, which is why we are unlikely to run out of them. IPv6 addresses are 128 bits in length and written as a string of hexadecimal values. Every 4 bits is represented by a single hexadecimal digit, for a total of 32 hexadecimal values. As shown in the figure, IPv6 addresses are not case sensitive and can be written in either lowercase or uppercase. Okay, 16-bit segments or exets. Segments or extets is the same. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 4 hexadecimal digits is equal to 16 binary digits. Preferred format. The previous figure also shows that the preferred format to write in an IPv6 address is this form, with HX consisting of 4 hexadecimal values. The term octet refers to the 8 bits of an IPv4 addresses, and IPv6 hextet is the unofficial term used to refer to a segment of 16 bits. Or 4 hexadecimal values, HX is a single hexet which is 16 bits or 4 hexadecimal digits. Preferred format means that you write IPv6 address using all 32 hexadecimal digits. It does not necessarily mean that is the ideal method for representing the IPv6 addresses. In this model, you will see two rules that help to reduce the number of digits needed to represent an IPv6 address. These are examples of IPv6 addresses in the preferred format. Okay. Number. Okay. Well, rule 1. Omit leading zeros. The first rule to help reduce the notation of IPv6 address is to omit any leading us zeros in any extet. Here are four examples of ways to omit leading zeros. 01AB can be represented as 1AB. 09F0 can be represented as 9F0. 0A00 can be represented as A00. And 00AB can be represented as AB. This rule only applies to leading us, not to trailing us. Otherwise, the address will be ambiguous. For example, the extet ABC could be either 0ABC or ABC0, but they do not represent the same value. Okay, type and format. Preferred no leading us. 2001 0DBA 0000. Okay, okay. Preferred. Well, the next point is rule 2, double colon. The second rule to help reduce the notation of IPv6 address is that a double colon can replace any single, continuous string of one or more 16 bits exted consisting all of zeros. For example, 2001 and DBA cave, okay. Leading us omitted could be represented as okay. um, the double colon is used in place of the 3 all 0 extet. Okay. The double colon can only be used once within an address, otherwise there will be more than one possible resulting address. When used with the omitting leading us technique, the notation of IPv6 address can often be greatly reduced. This is commonly known as the compressed format. Here is an example of the incorrect use of the double colon. Okay. The double colon is used twice in the example above. Here are the possible explanations of this incorrect compressed format address. Okay, yeah. If an address has more than one continuous string of all zero hextet, best practice is to use the double colon on the longer string. If the strings are equal, the first string should use the double colon. Type and format preferred compressed space. Okay, 0. Okay. Double colon is only with this rule. With this rule. Okay. We can see some examples. Compressed and compressed spaces. Is preferred compressed space compressed. Okay. Activity IPv6 address representation. Instruction. Convert the IPv6 address into short omit the leading zeros and compressed forms. Enter letters in lowercase. Click next to advance the activity to the next address. Preferred format omitting leading zeros compressed format. Okay, this is FA. Okay, this is only 1 0. only 10, only 10, only 10, only 10, only one, and okay. And compressed is FA 2 points. Sorry. And check. You have not correctly omitted leading zeros and are converted the IPv6 address to its compressed format. Please verify your entries and click check again. You can also click reset to try another IPv6. Okay. Okay, I know what is. 0, 0. Check. Incorrect. Okay. And next. Okay, compressed format is sorry. This is my bad. You have not correctly omitted leading zeros and are converted. Okay. This is my path. Show me. Okay. Okay. Okay, this is only 0, 0, 0, 0, 0, 0, 0, and 1. Check. Correct. Congratulations, you correctly omitted leading zeros and converted the IPv6 address to its compressed format. Okay, and one more. The compressed format is Correct. Congratulations. You correctly omitted leading zeros and converted the IPv6 address. Excellent. And next more. Okay. Correct. Okay. And this is all for this. See you in the next one. Bye.